Morning, all of you. In today's session, we are going to start with the 10th standard chemistry and physics, unit number 11, principles of metallurgy, series number 4 is going to be discussed. In the earlier session, we already started what are the different steps involved in the metal extraction followed by processing to give the purified one. In that, concentration of ore was completed. So in what way it can be concentrated, how many methods will be there, and what kind of process can be applied, that was completed in the earlier session. In addition to all these, unit number 1 to unit number 10 of this 10th standard chemistry and physics, entire detailed explanation available on the channel called World of Competitive Chemistry. Now we entered into the series number 4, where we are going to continue with the series number 3, where we started step-by-step process of purification, extraction, purification of the metal from its crude form from the earth crust. So in that, here second content is going to be discussed. Before going to enter into that extraction of a crude metal from the ore, we are going to continue with the concentration process only here. So let us recall the concept of concentration. Concentration is nothing but, so whenever metal extracted from the earth crust, it is in a combination of all the kind of materials. So already metal may exist in oxide, hydroxide, sulfide, sulfate, carbonate, bicarbonate. So these many forms, halides as well. So these many forms are possible. So along with that, some other impurities like sand, clay, soil, any other particles may associated with that kind of metal. So that's the reason why here the concentration of material is most important. Concentration can be carried by either hand picking, washing method, froth flotation, mechanical process, right? So these are the contents we discussed in the earlier session. So here is the diagrammatic representation of froth flotation, where we are applying this rotating chamber, which having the provision to rotate, intermix all the contents whichever present here. And here, what mineral, what ore we are taking, that can be crushed and added with suitable solvent, and here air can be bubbled into this one. After bubbling the air, what happens? Here the metal along with these bubbles are used to deposit at the top in the form of froth, and whatever impurities which are present in the mineral, in the ore, they get deposited at the bottom because of gravitational force, and these are said to be a gangue, right? So here most probably sulfide kind of ores, being these are least denser containing substances when compared to the gangue particles, they get floated on the surface, and they will be concentrated in this manner. This is the process called a froth flotation. And move on to another one called a magnetic separation. Magnetic separation is carried by taking the powdered ore here. So in this hooper, we can take the powdered crushed one ore can be taken here, and here we have wheels which having the provision to rotate. While rotating, so here these ore particles are used to travel through this one, traveling on this belt which is used to be surrounded these two wheels. And here, so here these wheels are having the provision of magnetism. Because of magnetic nature of wheels which are present, so magnetic substances get deposited near to this wheel, and non-magnetic substances get repelled and they will be deposited far away from this one. This is a kind of system called a magnetic separation. And let us go with a tabular form representation of this one. Right. So this is the table. This is a table which used to give the detailed description about the metals and their corresponding properties when they are treated with water, steam, oxygen, acids, and even halides as well. And this kind of discussion we are going to see in detail. So metals and their symbols are provided. Potassium, and potassium when added with water being it is S block element highly reactive, so that used to give the explosive reaction with the water. That's the reason we always S block elements most probably stored in kerosene. So here reaction will be somewhat vigorous in nature. And when we go with the steam, so when so normal water itself is doing with the vigorous conditions, whenever steam was taken, that is highly heated one, high temperature containing water vapor itself. That's the reason why the reaction is still explosive in nature. It is not preferable at all. Direct mixing of potassium with a warm or that boiled water or steam conditions are not at all preferable. And when it is treated with oxygen, so potassium upon treating with oxygen, being it is highly reactive, spontaneous reaction is possible, and first reactions you can clearly observe. And dilute acids, again, acids upon treating, so already we know that whenever any metal upon treating with acid, there is a liberation of hydrogen gas is possible. Hydrogen will be evolved during the addition of dilute acids. But so when these, being it is highly reactive in nature under normal conditions, so here reaction is somewhat vigorous in nature. That's the reason why it can be performed under controlled conditions. And next is about extraction process. How can we extract? What kind of mechanism, what kind of method we have to follow in order to extract this potassium? So potassium can be extracted by the process called electrolysis. So it can be taken in the molten state. Molten state of metal ore was taken and subjected to electrolysis process so that it can be obtained. And next is about sodium. Sodium is denoted with Na, called a natrium. And again, it is a member of S block element. That's the reason why upon treating with water, strong reaction is possible. Whenever sodium added to water, you will get expelling of water from that vessel. So here strong reaction is possible. And whenever steam was taken, still it is highly reactive. That's the reason why, again, we can see a vigorous reaction with this water upon high temperature conditions. And next is about oxygen. Being sodium is highly reactive, readily treated with oxygen, and the sodium oxide will be formed. And whenever it is added with dilute acids, again here we can clearly observe they are able to give hydrogen gas upon treating with acid, and the corresponding compounds will be formed. Corresponding salts will be formed here. Again, the reaction is highly spontaneous. And being it is highly reactive, electrolysis process can be applied in order to extract in a pure form. This is about the sodium. And next is about calcium. Calcium is a moderate. This is not that extent, and it is a member of alkaline earth metal. And reactivity with the water is somewhat less, and treated in the moderate conditions. And whenever steam was taken, being it is highly high temperature containing one, so that here again you can observe a vigorous kind of reaction. And oxygen reaction is also spontaneous in nature, and within the fraction of seconds you can clearly observe the calcium oxide formation. Quick reaction is possible. And next is about dilute acids. Whenever dilute acid was treated, the reaction is still vigorous, and again here you can clearly observe evaluation of hydrogen gas, and it is also extracted by the process called electrolysis. And next is about lithium. Lithium is a metal with a moderate reactivity, being it is the lightweight metal, and when it is added with the water, reactivity is spontaneous, but not that extent, that explosive, right? And upon treating with steam, it reacts in a faster manner. Strong reaction is possible with the steam. Steam is nothing but hot water vapor. Upon treating at more than 100 degrees, we can obtain that steam. And whenever it is treated with oxygen, so lithium oxide is formed in a spontaneous manner, and it is highly reactive towards oxygen. And next is about the dilute acids. And again, here you can clearly observe vigorous reaction is possible. So here, lithium able to form halides, sulfates, nitrates upon treating with these corresponding dilute acids, and hydrogen gas is formed. And here also you can apply this electrolysis process for this one. Next is about magnesium. So magnesium upon adding with water, so magnesium water addition, being it is sparingly soluble in a water, that's the reason why here reaction is not, reaction is somewhat slow manner. It is observed. And upon treating with steam, here you can clearly observe that it will be spontaneous in nature, and oxygen, the reactivity is somewhat low, and acid treatment gives the vigorous reaction, and here also we can employ the electrolysis process for its purification. Next is about aluminium. So being it is not soluble with a cold water, which is not able to give any reaction with water. Zinc is also insoluble, iron is also insoluble, nickel is also insoluble in water, tin is also insoluble, lead insoluble, copper insoluble, mercury insoluble, silver insoluble, gold insoluble, platinum. All these metals are not able to give any reactivity with the water. But with the steam conditions, aluminium will give a moderate reaction. Aluminium with the steam, there is a formation of reaction is possible, but the extent of reaction is somewhat slow. With the zinc moderate reaction, you can clearly observe iron also reversible reaction in the sense iron able to form corresponding hydroxides and oxides, and as well as the product to reactant possibility, vice versa reactions are possible. Nickel reactivity is possible, but comparatively somewhat less. And next is about tin, no reaction, and here also lead, no reaction, copper, no reaction, mercury, no reaction, silver, gold. Being these are noble metal, they are not able to give any kind of reactivity towards even low temperature water, high temperature water as well. When we move on to aluminium reaction with oxygen, aluminium reaction with oxygens, aluminium oxide will be formed. Alumina, Al2O3 is the product upon treating with oxygen, and towards acid, moderate reactivity you can clearly observe. And again here aluminium can be purified, extracted by the process called electrolysis. Zinc upon treating with oxygen reacts when heated. Under normal conditions, zinc oxide may not be generated, but upon heating, extra energy is required in order to get zinc oxide. Moderate reaction towards the acid, being it is a member of D block element and a transition metal, moderate reactivity we can clearly observe for these metals. And here acid reaction is also in between. It is a bridging one. And next is about metal ore smelting. Smelting is the process which is specific for certain metals of transition. So these are moderate reactivity containing metals mostly subjected to this smelting process. Next is about iron. Iron is reacted with the oxygen upon heating as well, and a moderate reactivity towards acids. And the metal ore smelting, just like a zinc, here iron is also extracted by the process called smelting. And in case of nickel, reacted upon heating, just being all these are the members of D block elements, all are having similar reactivity towards oxygen. Nickel oxygen treating, nickel oxide will be generated upon heating, and nickel reactivity towards acids is somewhat moderate in nature. And metal ore smelting, here also extraction is possible, refining is possible by the process called smelting. And tin is also upon heating, they are, so that is nothing but, so zinc, iron, nickel, tin, lead, copper, mercury, silver, gold, silver, till mercury we can observe, till copper we can observe. So they are able to form oxides upon heating. Mercury, reversible reaction. Reversible in the sense product formed, again reactant to product. In that way, reversible. So in both the ways, reaction is possible. And the silver, gold, and platinum being these are noble in nature, they are not able to give any reaction here. And in case of their extraction process, so here zinc, iron, nickel are extracted by the process called smelting. All are having similar kind of nature. And lead is also by the process called smelting. Copper, so we have a special method, heat or a physical extraction. So heating is required. For this purpose, we have a specified kilns called furnaces. So in order to extract these kind of materials, being all metals having high melting and boiling point values, so here heat requirement will be there. A special kind of devices are required in order to extract them. So here this process is possible in this metallurgical process called a heat or physical extraction. Not only this one, not only this copper, even mercury, silver, gold, platinum, all are having the same kind of nature, and they can be extracted by the treatment of heat. Being all these are noble in nature, so mostly available in the form of native state. Whatever impurities are there, they can be removed by the process called heating, and also physical extraction can be applied. No chemical reactivity will be there for these. Right, so this is about the table which illustrates how these metals are reacted towards water under normal condition, water at elevated temperature, oxygen and dilute acid reaction, and what kind of extraction method can be applied for these individual metals, right? So this is about the process of, this is about the properties of metals towards various reagents. So after getting that clear information, another concept will be extraction of metal from its ore depends upon the reactivity of the metal. So some of the metals are reactive, some are moderate, some are more stable in nature. So because of its nature, the type of method to be suitable can be predicted. So what way is suitable in order to extract in an economical way? So that kind of strategy can be studied by the process called metallurgy. So in order to get that, here are different kind of methods can be applied in order to extract the metal in the purified state, right? So in order to know that one, first of all, we have to understand what are the properties of these metals towards water, steam, dilute acid and chlorine. Just now we studied, just now we got on a tabular form, right? So in what, if it is highly explosive, highly vigorous, we are not supposed to adopt that method. If it is very smooth and slow manner, but giving economical product, that method is suitable and better to adopt that method. That's the reason why what table we studied is a very important criteria in order to choose the better method, in order to adopt the better method for the extraction and eventually purification of that kind of metal what we are extracting. So here, so reaction of metal with the water was taken, different metal pieces were taken and added with the water content, and even steam, high temperature conditions, steam can be applied here, and even acid. So we may take hydrochloric acid, we may take nitric acid, we may take sulfuric acid. So any of the acid was taken and a pinch of metal will be dipped into that one, so that what kind of reaction we are going to observe. So this is a kind of process. So we saw already table. The table represent what? The table represents inferences what we drawn after doing this experiment, after doing these experiments, what inferences we drawn, that is the tabular form. And this is the method of performing the activity. How it will be? We are taking a beaker, added with the water, a pinch of metal will be added, and what kind of inference you are going to draw, whether it is soluble, whether it is insoluble, whether any gas release, whether any solid precipitated, that kind of method we are going to do here. And next is about steam was taken. So high temperature conditions are provided here, and metal will be added to that steam. And what kind of changes you are going to observe. And here also various acids and various metals are dipped into that. And these values, these inferences you are going to tabulate in that way. And this is about the reaction with chlorine gas. So not only chlorine, you may take any halogen compound, and what kind of reaction you can clearly observe with these metals. So this is a kind of experiment what we are going to perform. And already we know the tabular form of various metals where the reactivity order will be provided here. And the reactivity order will be in this manner based on its reactivity. Based on its reactivity, we can choose the suitable method for its extraction, right? Here always in this tabular form, the metals of high reactivity will be there, and the metals of a stable nature will be placed here, right? So here there is a distinction line between all these called the hydrogen. Hydrogen used to distinguish between the metals of high reactivity and stable nature. So below hydrogen, the metals are said to be stable in nature. Above this hydrogen, more reactive in nature. So this is a kind of tabular form which used to illustrate the reactivity, comparative reactivity of all the metals. Comparative reactivity, right? So the very important thing in order to choose that one will be the nature of metal. In what way it will be interacted with the reagent added. So based on its reactivity, based on its properties, the type of method is suitable for the extraction can be studied. The method used for the particular metal in the reduction of ore depends mainly upon the position of the metal in the activity series. So where it is located, based on this, we can easily select the type of method required to extract this one. So here, that's the most important thing. Where is the metal is located in that reactivity table. And next is about simple chemical reduction methods, like treating with carbon monoxide. Such a kind of reagents can be applied on these raw materials so that here extraction can be carried. This is called a chemical treatment, and eventually they got reduced. So whatever the process we are applying, finally we are getting metal, pure metal. That is nothing but metal plus N oxidation state finally converted into metal zero oxidation state. That's the reason why always metallurgy is chemically denoted as a reduction process. Metallurgy is chemically denoted as a reduction process because plus to zero oxidation state always requires the addition of electrons. Hence, we can say it is the kind of reaction called a reduction. Right. So here so many methods can be applied. Here chemical reduction process applied by treating with carbon monoxide. So to reduce the metal, and the temperature is required to reduce it too high and expensive. The process to make the process economical, electrolysis method can be adopted. So here thermal conditions and electrochemical conditions can be applied. That depends upon the suitability, that depends upon the economical constraints. Right. So this is about the type of process we are going to choose for the extraction of metals. And next is about, again, electrolysis of aqueous solution is not feasible because water is a solution would be discharged at the cathode preference to the metal ions. So in general, whenever electrolysis applied, what happens, metal will be deposited at the cathodic region so that a pure metal can be extracted in this manner. This is a general process whenever we are applying the electrolysis and subjecting it to a passage of current from the external source into this container. So metal will be deposited at the cathodic region in general. The only method available to extract the metal by electrolysis of their fused compounds. For example, sodium from the sodium chloride. Sodium chloride is denoted as a brine solution. The sodium chloride brine solution get electrolyzed with a steel cathode and a graphite anode. Right? The brine solution was taken in the container and two electrodes were inserted. One of the electrode is a cathode denoted with negative. Graphite is the anode electrode with a positive. So when this brine solution is subjected to the electrolysis, passing external electricity, what happens? Sodium will be deposited at the cathodic region. Generally, in the metallurgical process, cathode is being deposited by a metal one. And at the anodic region, gas will be evolved, that is the chlorine, being it is a sodium chloride, sodium at a cathodic region, chlorine in the form of chlorine gas evolved at anodic. So chlorine bubbles we can clearly observe at anodic region. And this is about the chemical reactions whichever possible in between two electrodes. At the cathodic region here, sodium positive will take two electrons and it is converted into sodium metal. This is the kind of system. Here it is clearly depicted that positive accepting electrons converted into sodium metal, being it is a reduction. Always metallurgical process are denoted as a reduction. They are able to accept the electrons and convert it into pure metallic state. Anode can be anode chloride ions. Being chloride ions are associated with negative charge, so that here negative charge is losing electrons in this manner and converted into chlorine gas, and that will be evolved at anodic region. In this electrolysis, larger quantity of electricity is required. So because we have to supply the electricity, then only here separation of these ions into their corresponding neutral form are possible. Suitable impurities are added to the ore to decrease its melting point. So some of the impurities when added, what happens, their melting point will be reduced, so that the process will become easy and the consumption of electricity will be reduced here. Extraction of metals in the middle of the activity series. When we go with the zinc, iron, tin, lead, and copper, the ores in general, they exist in the form of sulfide. So here it is clearly depicted. When silver was there, argentite, we can say it is called argentite, that is Ag2S. So from this we can extract the argentinum called Ag. And next is about copper pyrites. Copper pyrites is copper iron sulfide, from which the extraction of copper metal is possible. And next is about galena. Lead sulfide is called galena, from which we can extract economical quantity of a lead. Cassiterite is nothing but tin oxide, from which tannum can be extracted. Dolomite is a carbonate, or magnesium and calcium carbonate will be there, and from magnesium can be extracted. Bauxite is Al2O3 hydrated form, aluminum can be extracted. So these are the kind of ores and their corresponding names from which the metal can be extracted. That tabular form is given. When we are taking these metals, these are said to be a moderate reactive one. Zinc, iron, tin, lead, and copper, mostly these are the transition metal, the block elements. So when we are taking zinc, sphalerite is the ore of this zinc. Iron extracted from iron pyrites, lead extracted from the ore called galena, copper from copper iron pyrites, and tin from cassiterite. So these are the minerals, and their corresponding metal extraction was given in this slide. And this is about another process called a roasting, where we are taking the combined form of metal and subjected to heating. So in general, here metal of sulfide can be taken here. Roasting can be suitable. So generally, we already saw the flow chart of metals, where metal sulfides are subjected to roasting process. Roasting is defined as sulfide ores converted into oxide ores by heating strongly in the presence of excess of air. So when we are taking excess of air, so here you can clearly observe how the roasting process get carried. Here sulfide ore was taken. That sulfide ore is heated at high temperature in the presence of oxygen, so that oxygen get mixed and sulfur will be removed. So here metal sulfide now in turn converted into metal oxide. So this process, this entire process carried in the presence of air, hence it is called a roasting process. So roasting process to give sulfide to oxide ore, oxide metal, right? So sulfide in turn converted into a oxide one. And next is about extraction of metal. When lead sulfide was taken, what is the lead sulfide? Here we can clearly see lead sulfide was taken called a galena, and that is treated with oxygen, and which is converted into lead oxide, and sulfur dioxide will be generated. Lead sulfide converted into lead oxide, that is the process called roasting. The metal oxide are then reduced to the corresponding metal by the suitable reagent called carbon. So here carbon is the reagent which used for the process called a reduction. Carbon is a better reducing agent, right? So that's the reason why it is used, the metal oxide. So after generating this lead oxide, it now treated with the carbon so that oxygen removed and a pure lead formation is possible. This is the process called a reduction. After roasting, next step will be a reduction with the chemical reagent. Now, so here it is clearly depicted, reduction of metal oxide with the carbon. The oxides are reduced by coke in the closed furnace. So coke is nothing but that is the powdered charcoal, powdered carbon itself. So here oxide form of that metal was treated with this coke, and upon treating, what happens, this oxide now removing oxygen. Removing oxygen is called reduction, because here we have a +2 oxidation state of lead. After treating, it is converted into zero oxidation state. +2 to 0 is nothing but decreasing the oxidation state by gaining of electrons. Hence, you can say this is a process called reduction, right? So here in the presence of coke, it will be reduced, and the optimum temperature conditions are 1400 degrees centigrade. So that's the reason why we need such furnaces. These furnaces are used to provide that extent of high temperature called 1400 degrees centigrade. So here lead oxide upon treating with carbon at 1400 gives rise to a pure metal lead, and in either byproduct carbon dioxide that is evolved in the form of gaseous state, right? So it is clearly depicted here, lead oxide upon treating with carbon, pure lead will be generated, and here carbon dioxide will be discarded. And next is about iron oxide. Iron oxide was taken and treated with carbon monoxide. Here the reducing agent is carbon monoxide. The suitable furnace for this one will be a blast furnace. So such a kind of device which used for high temperature heating kiln is called a furnace. And here iron oxide treated with carbon monoxide and pure iron and carbon dioxide will be evolved. Here is the chemical reaction depicted. Iron oxide upon treating with carbon monoxide, there is a formation of pure iron and the carbon dioxide will be evolved during the process. And next is about auto reduction. Auto reduction in the sense extraction of copper with a sulfide ore, the subjected to partial roasting air to give that one. Where copper sulfide upon treating with oxygen, auto oxidation in the sense when it is placed in the open air need not to add any external reagent, because air by default it used to give the oxygen, right? That's why copper sulfide is turned into copper oxide and the sulfur is converted into sulfur dioxide. So that is called auto oxidation. We are not going to do anything externally. So copper pyrites upon treating with oxygen, copper oxide will be generated here and sulfur dioxide will be the byproduct. And in either reaction, when we supply the air, so here copper oxide formed, but it is not the pure one. That means this is not the pure metal. So we need to continue the reaction until copper metal will be obtained. That's the reason why generated copper oxide again treated with copper pyrites. That means a copper sulfide will be added. Copper oxide now treated with copper pyrites, copper sulfide, so that here both get mixed. Now what happens here? Itself it is an oxide, itself it is a sulfide. Both are reacted in a spontaneous manner, and in general generates a copper metal, and in either byproduct will be sulfur dioxide. For this purpose, we have two steps. Initially, we are taking pyrites. Open air reaction is possible. Pyrites sulfide converted into oxide. So this generated oxide now treated with again pyrites. So what happened? Both get reacted and gives rise to a copper metal. Along with that, another byproduct, that is a sulfur dioxide, will be generated. Right now, a reduction of ores by more reactive metals. So here, when more reactive metals are there, in that case, what we have to apply and what method we have to follow. Thermite process involves the reaction of metal oxide with the aluminum, right? So in the thermite process in general, the purification is possible by the reagent called the aluminum. When highly reactive metals, when taken, highly reactive metals such as sodium, calcium, and aluminum was taken, and reducing agent displays the metal of lower reactivity from the compound. So this thermite process can be applied so that what happens, this used to give high heat condition, high thermal heat will be evolved during the reaction that can be applied, that can have a further applications also. Whatever heat evolved, that have further applications also. Let us have a detailed explanation about this thermite process. Thermite process is nothing but it is regarded as an exothermic reaction. While treating reagents, heat is evolved during the process where aluminium metal and iron oxide react to form aluminium oxide. What we are taking, aluminium metal was taken, iron oxide was taken, aluminium oxide will be generated and iron metal will be generated. It reaches very high temperature and causes the metals to melt due to the heat reached. So during that reaction, one of the reagent, aluminium metal is there, iron oxide is there. After the reaction, aluminium turned into oxide form. This is called a combustion process. Combustion process used to give a heat, a high amount of heat will be evolved during the reaction, and it is said to be a exothermic. These displacement reactions are highly exothermic, and the amount of heat evolved is so large in nature that metals produced are molten state, because whatever metals we are extracting, that will be in a molten state, because along with the reaction, high quantity of heat evolved, that heat will melt the metal. Here you can clearly observe how aluminium is turned into a molten state by this exothermic reaction called a displacement reaction. And another process called extraction of metal in the middle of the reactivity series, like a titanium tetrachloride, being it is also the member of transition metal, and upon treating with a high reactive metal called a magnesium, and heat will be applied at 850 degrees centigrade. Titanium tetrachloride, it is in the halide form, right? So at this heating condition, pure titanium will be obtained, that is nothing but +4. Here, what's the oxidation state of titanium? +4 oxidation state. After this reaction, it converted into a titanium metal of 0. It simply reduced, and along with this, magnesium got accepting chlorine and in turn converted into magnesium chloride. In the same manner, titanium tetrachloride either treated with the sodium in the similar pathway, so that here pure titanium metal along with the sodium chloride will be obtained. So this is about the method for the extraction of titanium by treating with the most reactive. This is also the kind of thermite process. In general, thermite process can apply aluminium, but along with aluminium, we can use these metals also. And here is the clear depiction for this one. Here, aluminium metal is treated with the iron oxide Fe2O3. Here, aluminium is converted into Al2O3, and the iron purely extracted in the form of Fe. Along with this reaction, high heat will be evolved during the reaction. This heat cannot be wasted, and indeed, it can be used in joining the railing of railway tracks, and also whatever cracks are present in the machinery, so that welding is also possible. We can harness this kind of heat whichever evolved during this thermite process. Why it is known as thermite in the sense? Because high thermal heat will be evolved during the chemical reaction, so that can be utilized in a proper way. Hence, it is called a thermite reaction. And this is the method of application of that thermite process. Here, what we are doing, for example, railway track is having certain crack here, and we are supposed to use what we are using, aluminium can be applied here. So that aluminium metal, when applied with this one, what happens, that aluminium get treated with this iron oxide, so that here aluminium oxide will be generated and iron will be formed along with that high heat. Here you can clearly observe the extent of heat evolved during the reaction. This heat is used to melt the surfaces of these railing. So now upon this melting state, what we can do, so these two molten surfaces, molten terminals get connected, and here it is clearly visible to us, both get connected by the process called thermite, where the heat evolved during this thermite process is used for the connection. That means welding purpose, we utilized this one. This is a kind of application of the scientific terms. Scientific concepts can be applied in our daily life. Metal at the bottom of activity series often found in a free form, and being it is more stable in nature. Their reactivity, other atoms are comparatively low, but they are more stable in nature. And oxides of these metals can be reduced by heating alone, sometimes by displacement reactions. So heating is the suitable method for the extraction from their oxide forms. So if they are present in sulfide, roasting is a suitable way. If oxide is there, the method is heating. That means rising the temperature to very high so that oxide get converted into a reduced form of pure metal. So this is for the metals which are stable in nature. Now, we are going to discuss about extraction of metals at the bottom of activity series. Bottom of the activity series, we have platinum, we have silver, we have mercury, we have aurum. All these metals will be there and they are stable in nature. And we are taking a simplest example, mercury. Mercury sulfide, being it is denoted as a cinnabar. Cinnabar is the ore of mercury from which economical quantity of mercury can be extracted. And this cinnabar can be heated in the presence of air. So in the open air, that's subjected to heating. So while heating, silver sulfide converted into oxide form, right? Silver sulfide converted into oxide form. This is called roasting. Now reduced to mercury on further heating. Still, we are going to continue the rising temperature so that here pure form of mercury will be obtained. One and only one liquid metal in the entire periodic table, that is mercury, and being it is the member of this noble metals. Silver sulfide, upon treating with oxygen and rising the temperature to very high, so that here mercury sulfide converted into mercury oxide along with the sulfur dioxide will be generated in the gaseous form. This is simply denoted as a combustion process. So heat will be absorbed and here sulfur dioxide will be liberated. Still, we are going to continue the process. This silver oxide get heated, and that silver oxide, when continuously heated, oxygen will be removed, and finally we will get mercury, and oxygen evolved from the reaction. This is about the extraction of a crude metal from these metals of which are present in the table, right? So here another process called displacement. Displacement in the sense existing one is replaced with some other is called a displacement reaction. So for example, I'm taking what silver sulfide. Silver sulfide will be taken and treated with cyanide. So what happens? Sulfur being replaced with the cyanogen. So here silver cyanide will be generated, and the sulfur S-2 will be evolved from the reaction called as sulfide. S-2 is denoted as sulfide. Whatever silver cyanide is generated, which can be treated with zinc metal. Zinc metal will be treated. So when zinc metal is treated, what happens? So here compared to silver, the reactivity of zinc will be more. That's the reason why obviously it will replace silver, so the pure form of silver will be obtained and the zinc is converted into zinc cyanide. So here pure silver will be extracted here. Here, silver sulfide is dissolved in a potassium cyanide to get the dicyanoargentate. This is the complex which is regarded as dicyanoargentate. So here, dicyanoargentate further treated with the zinc powder, zinc dust powder will be added, being it is more reactive. This reaction, this displacement purely based on its reactivity. Zinc more reactive when compared to silver. That's the reason why it will be added, and here silver will be evolved during the reaction and the zinc cyanide formation is possible. Why this? We completed the extraction process of various metals, and various kind of different methodologies will be applied, and that purely depends upon the reactivity towards various reagents, that kind of reactivity towards water, towards steam, towards oxygen, towards halogens, towards dilute acids, and what kind of extraction process will be there for various metals. All these are exclusively studied in this session, and what is meant by thermite process, and how can we harness that heat evolved during the reaction for the application, right? So all these topics were discussed. Hope this session will be helpful for your preparation. Thank you very much. Thank you for your patient listening.